Hi, welcome to the next stage of the build of my solar accumulator. This has been a bit of an ongoing project for a while now. Time always gets in the way of finishing these things off, but off camera I've drilled all of the holes for the USBs. I've got two USBs here, 2.1 amp 5 volt DC. They've got little voltmeters in them. This one here I've decided to go for a quick charge 3, which has got two quick charge outputs in it, so they're up to sort of like 15 volts or 12 volts or whatever they are. I've got another USB here, and then I've got three, these are 5.5 by 2.5 connectors. This one here is very annoying. It's gone off. Sorry, I'm hand holding, so I'm a bit wobbly today. It's gone off center very slightly. One of the annoyance of plastic and drills, but it's all wired up except for this thing, which can't be wired up until I've assembled the whole unit into the battery pack. Excuse this wire, this is from testing. It goes to the bench power supply. These are all wired in. Bit of a, well, not the neatest job in the world, but it's as neat as I can get it in the confines of the very small space, because although it looks big on the camera, this is all just like a couple of inches across. It's quite a lot of quite a small area for it to actually be soldered into. I elected not to solder this one, just in case I want to use it in another project at some point. It was quite expensive, this quick charge 3 one. These are kind of like jelly bean, couple of quid each. This was sort of like £12, quite expensive, so I've decided to leave that one alone. I've just been doing some testing on my bench power supply, hence the croc clip. Interesting enough, these at idle, when there's nothing plugged in, are pulling about 40 milliamps each, so I'm quite pleased that I switched them. I was thinking of leaving them unswitched and just leaving them on the battery the whole time, but the two of these together would consume 80 milliamps, which is quite a heavy amount of current to be drawing when they're not doing anything. So I'm glad I've switched them independently now. This one, interestingly enough, is only about 20 milliamps, so it's using a lot less power, so it's obviously more efficient modern technology in that one, probably due to the higher price. But I'll just power it up and I'll show you how it works. Okay, so I've powered it up, or I've applied power via bench power supply onto the power connector here. I'm using these, I forgot what they're called, EC3s I think they're called. This is going to be so I can remove the lid and disconnect it from the power source in the actual main unit of the main body of the unit when I've actually built that section. But for the time being, I'm just concentrating on the lid. Like I said, the display won't work because that's the other half of this that makes this work is in the other unit, which isn't built yet. But I can switch all these on. This one is busy charging a rather large power bank, and powering an overhead light as well. At least it would be if I turned it on. There we go. The QC3 is actually charging the phone that I'm recording this on, and then this one here is powering a USB light. These have all got little voltmeters on. They're currently saying 7.6, 7.8 volts. I wanted to test its low voltage ability, so I'm lugging these. Actually, this one isn't working. Oh, set it on. That one won't work. It's pulling the power too low. Oh no, it is working. Yes, it's working. I've got my bench power supply set at just under 9 volts, and it's pulling 1.3 amps with these. So that's quite a few watts. About 15 watts, I suppose, isn't it? So this is the QC3 output. This is charging my phone, which I'm recording this on. This has got a light which has gone off. It's obviously dropped below its, yeah, this light here, my ring light, won't run at this low voltage. This one is also powering a power bank, charging a power bank, and this one here is driving just a very dim LED light. if I up the voltage on the bench power supply, sorry, I'll tie myself up with the charge wire. So if I up it to say 10.8, which would be like the nominal battery voltage, right, we're pulling just under 1.5 amps. This may work now. Yes, it does. So this will now work. Interestingly enough, it's showing a massive voltage drop on this voltmeter, and this one here, both showing at 7.9. Actually, my bench power supply is current limiting. Right, there we go. That's why the voltage has dropped. So when I'm not current limiting, this quite happily pulls, showing 10.8, 10.9 volts. These things aren't super accurate, they're just designed as a rough guide, but I can switch them on and off independently. Like I say, this one's got a USB light in it, on and off. These I've not tested yet, but I'm assuming that as they're all connected up, they should work, and the little telltale light is working. This works. So it's now turned my phone off charge, put it back on to charge, and this one here switches this on and off. So it's all working as it should, which is what I wanted to test tonight. So the next part now is to build the actual power supply for this, which is going to be more involved, more complicated, and perhaps a little bit more fun for me. More assembly and perhaps a little bit less soldering in confined spaces. So keep a lookout for the next instalment of this rather strange, crazy build that I'm doing. Thanks for watching.